Have you ever felt like sets are just random collections of things? In reality, sets follow a strict set of rules, literally. Whether you're into computer science, logic, or just ACING your math exam, the laws of sets are the hidden grammar of mathematics. Today, we're breaking them down. These are some important laws, but we are going to learn all of them. A set combined with itself is just itself. Simple. Putting two identical piles of books together just gives you the same pile of books. Let's take some example. The double purchase. If you buy a set of pens, A, and then buy the same set of pens, A, again, you still just have the set of those specific pens. A, union, A, equals, A. Venn diagram overlap. If you shade the circle for setter twice, the area covered remains exactly the same as shading it once. Class membership. A student in the math club who joins the math club is still just a student in the math club. Commutative. The order doesn't change the result. Simple. A union B is the same as B union A, just like 2 plus 3 is the same as 3 plus 2. Let's take some more example. Grocery list. Adding milk, then bread to your cart is the same as adding bread, then milk. M union B equals B union M. Team selection. Choosing the goalkeeper and then the striker results in the same team as picking the striker first and then the goalkeeper. Mixing colors. Adding yellow paint to blue paint creates the same result as adding blue paint to yellow paint. Associative. The way you group them doesn't matter. Simple. Adding A to B plus C is the same as adding A plus B. To see some examples, sorting laundry. Whether you group socks plus shirts and then add pants, or group shirts plus pants and then add socks, your total pile of clothes is the same. Study groups. Combining math group plus physics group, then merging the chemistry group is the same as merging math with the physics plus chemistry group. Digital folders. Moving files into subfolders follows the same grouping logic. The contents of the master folder remain unchanged. Distributive. Intersection multiplies over a union. Simple. Like A, B plus C equals AB plus AC, you apply the intersection to both parts inside the brackets. Some more examples. The club rule. People who are athletes and students who are teachers equals people who are athletes and students or athletes and teachers. Pizza toppings. People who like mushrooms and pepperoni or onions equals people who like mushrooms and pepperoni or mushrooms and onions. School subjects. Students who like math and English or history equals students who like math and English or math and history. Identity. Combining with nothing keeps it the same. Simple. A union empty set equals A. Adding nothing to your set doesn't change your set. Let's take some more example. The empty box. Adding an empty box to your collection of tools doesn't change the tools you have. Tools union empty set equals tools, the universal set. If you are looking at all students in a school, the students who are in the school and in grade 10 inches is just the set of grade 10 students. Inventory. Checking your current stock against a zero stock list leaves your inventory exactly as it was. Complement. A set plus its opposite equals the whole universe. Simple. Even numbers plus odd numbers equals all numbers. This examples will explain more. Gender. If set A is male students, then a complement is female students. Together, they make the universal set, all students. Light. If set A is lights that are on, then a complement is lights that are off. Together, they represent the status of every light in the house. Numbers. If set A is even numbers, then a complement is odd numbers. Together, they represent the set of all integers. Domination. The universal set wins in a union. The empty set wins in an intersection. Simple. An intersection empty set is always empty set. You can't have an overlap with nothing. Let's understand it with more example. The universal invite. If you host a party for anyone in the school, $U$, and add a guest list of people in class 10, the total list is still just anyone in the school. The intersection void. The set of people who are students at CMS and students at a school on Mars is empty set because there is no overlap. Product quality. If you take a batch of products and intersect it with a list of defective items that don't exist in that batch, the result is empty set. Absorption. The smaller set is swallowed by the bigger set. Simple. If your set is a subset of another, the larger one dominates the union. Let's take some more example. Subsets. If set A is all dogs and set B is all animals, then a union B is just all animals because dogs are already in the animal group. Rankings. A top 10 inches list absorbed into a top 100 inches list is just the top 100 inches list. Business. A specific department, A, intersected with the whole company. A union B is just the department itself. De Morgan's. A clever way to flip a union into an intersection. Simple. The not of A or B is the same as not A and not B. Some more example. The not rule. Not tall or are strong means you are neither tall and neither strong. The filter logic. It's not Tuesday and raining equals it's not Tuesday or it's not raining. Security. If you say, I don't want apples and oranges, it means you are happy if you don't get apples or you don't get oranges. Double complement. The opposite of an opposite is the original. Simple. Not A, brings you right back to A. Let's make it more easier. The not toggle. Not happy simply means you are happy. The truth switch. Not true is just true. Directions. Not turning left means you are turning left. And that's the complete list. Remember, these 10 laws are the backbone of everything from computer logic to advanced statistics. Once you see these patterns, you'll stop memorizing math and start seeing how it works. If this guide helped you clear up the confusion, hit that like button and subscribe so you don't miss our next deep dive into the world of mathematics. Thanks for watching, and keep on learning.